Alright, time for another draftphysics.com, debatephysics.com, but really, it's unfortunate that there's just no volunteers to have an actual conversation about the experiments that have been done and the history of physics and how decisive the evidence is, what's really hard evidence, what's kind of fudgy and mushy evidence, and there's just nobody who wants to do that. Uh, which is sort of like religion, right? There's not too many religious people want to argue about the volumes of evidence regarding evolution. So anyway, so Jim Al-Khalili, I thought I would just go over a part of the video where I might have misspoke a little bit when they're talking about a spark gap and shining electrons. I mean, shining light on the electrodes. The more significant experiment was done with the whatever you call it, somebody's ladder. And the idea is that they found if they just shined light on the air molecules between the spark gap, that would make a spark more likely. So the ultraviolet light shined on the air molecules would create ions that are basically help make the conductor that the spark travels through. So it's not only just about how much charge you have differential, right? So the ultraviolet light shined on the metal will increase the positive potential. So the positive side, you can increase how positive it is, and by knocking more electrons off of it. I don't think it'll work the other way around. So yes, you can shine on the metal, but it was shining it in the air that was, I think, the more significant experiment. So anyway, just want to make that clarification. All right, continuing.
That moment at the beginning of the 20th century signaled a genuine revolution because it demonstrated that the kind of...
So they're all revolutions, right? I mean, the steam engine was a revolution, and the light bulb's a revolution. Everything's a revolution. And obviously it's part of the evolution, okay, and all of it is significant, okay, Wright brothers, all kinds of things, all of it, but to say that one moment was bigger than the other moments, not a very, I don't know. Putting them all together, all the events, would be interesting, just to see where there was a gap of 10 years where nothing interesting happened. But that's about all it'd be good for.
Physical science that people were doing right back to Newton and Laplace and people like...
Right, so if you went back to Newton, that's the whole argument, then you'd realize, well, there was really no good reason to change the definition of energy. Newton told you twice the force, twice the velocity. So why do you think something else is true? Do you have a good reason? And then maybe you'd re-examine denting clay with round objects and figure out that's not too good an idea. And then maybe you'd go to those cart experiments that create free momentum, where you make extra momentum. Maybe you take a look at those carts and say, hey, guess what? There's a whole bunch of energy stored in the wheels. No, you didn't do any of that.
That you needed a completely new approach.
So this whole idea that somehow you have to revolutionize, what goes up comes down, some of it is just so mechanical and obvious, and like I said, you go all the way back to Descartes. I think Descartes was the first person to really say it out loud, that the energy just travels through the universe. It's the same energy, and it's just moving from place to place, and you just follow the momentum, the masses moving velocities.
Physics is never...
So doing this again, they're back to this stupid erectile thing, playing with it. It's just like, come on, you're this. I mean, you can't hide that you're still 13-year-olds a little better.
Recovered from that moment in the sense that it's built on that moment. That's where modern physics really began.
So whatever. It obviously began with the idea that you let Einstein get away with murder. I mean, it began with the idea that you didn't understand how gravity worked, okay, and you thought the distance was proportional to the energy, when that doesn't make any sense at all, because the distance isn't proportional to the velocity. So, and getting that wrong, not understanding that gravity is a simple time-dependent force that Newton told you, Galileo told you, 9.8 meters per 1 second. So 1 second of being free falling, you get 9.8 meters. In the second you get another 9.8 meters of velocity. The third second, you get another 9.8. That's all. You can't get that right. I mean, I don't even know how you got that wrong. I mean, how you could mess up something so it's an obvious ratio. It's 9.8 to 1 second. How can you mess that up?
But
look, they're obsessed with it, right? Now, so the telescope has absolutely nothing to do with the story at all. In 1915, when Einstein did his revision to his relativity theory, he gave a lecture at this telescope location, and that's it. That's the only reason why it's here. So this is just so they're not even showing us a picture taken with this telescope. And obviously, you could explain the engineering of it. You could say, well, look, there's two ways you can make a telescope see better. You can make the lens bigger, or you can make the distance between the lenses bigger. Obviously, this is doing the distance thing, which is sort of relevant to Eddington, actually, because Eddington actually used a 12-foot long telescope. So he actually was taking advantage. There's advantages to the longer versus the bigger, fatter.
Einstein's theory also left physicists with a dizzying paradox, defying all common sense. Light was definitely a wave.
So we know it wasn't definitely a wave, and it never matched the water example. The water's oscillating, photons aren't oscillating. I mean, there's so many ways it doesn't match. And then their own math, the center of the waves has to be the surfaces. They're using the math to the center of the waves, right? I mean, that's what your vectors are, is the center of the wave. And obviously the center of the waves would have to be over the surface of the impediment. How did the wave originate over the impediment? It can't happen. So it doesn't match really at all. And they just keep pretending it's this perfect match. We can't draw any other conclusion. On-off pattern, the simplest pattern in the universe, always has to be interference. I mean, this is just, it's so silly. Jesus did it. They might just, just say the words. Jesus did it.
Which explained shadows and bubbles.
So again, the shadow argument is bullshit. Look, he has a perfectly seeable, resolvable shadow. If it was waves, okay, the shadow be wiped out in a matter of inches of distance, because the water rushes, because it's going in all directions. The diffraction is gigantic, where light bending is just a tiny bit of scatter. So again, wrong.
And now it was definitely a particle too. Einstein's quanta, explaining the photoelectric effect and the ultraviolet.
And look, and why couldn't you just come to the simple conclusion that particles could look like they're waving, but waves can't look like a particle? Get real. There's no way to keep any of the features of a wave and then say the wave is making a laser beam or a ray. So you already know that the wave theory is the deficit theory. And even in spite, and then on top of all of this, he's making this video in the 2000s, and in 1980, Feynman, a guy he has this huge amount of respect for, Richard Feynman, told you it's not a wave. So quit playing with the words and quit pretending it is when it isn't a wave. All right. The thing don't work that way, to quote Feynman.
Catastrophe. Then, just a few years after Einstein's brilliant, crazy idea, the paradox got a lot deeper and a whole lot weirder.
So it's not just it's 1926, 5. Now, this lie is just such a gigantic lie. It's just such a distortion and perversion of the truth. There's so little truth in what he's saying. And you're just saying, well, why would they have to do that? Why would he have to tell this story that is so not accurate if this is good physics? Why would he have to rely on making just insane statements, misdescribing the reality?
Because what seemed to be a curious mystery about light was about to become a battleground about the nature of reality itself.
La 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 la. So again, yes, eventually it gets to Bohr and Einstein. And frankly, it should have been about a lot of people. I mean, there should have been a lot more people arguing this crap than just these two people to tell us what reality is. Because, yeah, Einstein just didn't do a good enough job. Well, I mean, he did a pretty good job. He said, look, the moon doesn't disappear. Do you think the moon disappears when we're not looking at it? Pretty good argument. You think the damn cat is alive and dead? You think particles have ESP and communicate with each other over insanely long distances instantaneously? You think that's really possible, you Looney Tunes? So really, he didn't do anything wrong. I mean, obviously, his entanglement argument just made a joke out of their physics, and somehow they doubled down on the joke and pretended, yes, gremlins are real. So all of this again. Now, this isn't bad just because the song isn't bad, but it's just what a waste of time.
1922. The Western world is in the grip of a revolution, a cultural revolution.
James Joyce's Ulysses is published. Stravinsky is at the height of his powers.
And what, Babe Ruth hit 4 home runs? I don't know. Is Babe Ruth still playing then? I don't know.
And Chaplin has just released his first serious movie, The Ottoman Empire.
Yeah, that's all stuff I really would have cared about if I was alive then. I would have just been so fucking interested. No, I don't think so.
Collapses. Europe is still recovering from the war to end all wars in which
I think I just would have noticed that women ain't wearing much clothes. That's cool.
millions of men lost their lives. Russia is newly communist. Meanwhile, America is exporting jazz to the world. Thank you.
And really silly hats, I gotta say that. The 20s was the silliest hat moment in history.
In art, politics, literature, economics, there was an insatiable appetite for change.
And everybody was a drunk.
This was the birth of modernism.
You got a heart, but there's no way of knowing. Can see where you are, but can't see where you're going. And I'm stuck here still.
So she's got a good voice. It's nice.
I'm tangled
But this has nothing to do with fucking physics.
up with you. This whole world can be so uncertain.
But, and I might get into trouble for saying this, I would argue that the upheaval that took place in physics at this time would eclipse them all.
Only in your mind. So, yes. Only in your delusions. You didn't eclipse anything. You didn't make anything. None of this crap had anything to do with anything invented. It's all just aggrandized, silly stories. Believing in your woolicles did not make the nuclear bomb. None of that crap happened because of this crap.
And have far longer lasting consequences. It had begun with the discovery of the weird and contradictory wave particle nature of light. It ended up as an epic battle fought between the greatest minds in science for the highest possible stakes.
I don't know what stakes there were. Yeah, what were the stakes? Yeah, you're all both going to die. Yeah, what did you win?
The nature of reality itself.
I know I deserve you. I know you're the savior. But when I observe you, you change your behavior so
Of side, a new wave of modernist revolutionary scientists and their leader, the brilliant Danish physicist Niels Bohr.
So this guy just ruined physics. I mean, frankly. I mean, the Bohr model was wrong. It's solar system thing, stupid. Forget it. Doesn't make dipoles, doesn't make ions, doesn't make anything reasonable. So forget it. It doesn't work. It's stupid. It breaks all the geometry. How do the electrons have the just right velocity? I mean, you know, shared electrons are doing a figure 8. I mean, too ridiculous in so many ways. And then on top of that, he does all this wooey shit. So, yes, big blunderhead. Ruined physics. Ruined it more. Like I said, it was already ruined by mv, 1/2 mv squared. That ruined physics.
On the other side, the voice of reason, Albert Einstein, at the height of his powers and now world famous, a formidable adversary.
Yeah, the only problem is that he can't really talk about spooky action when his whole gravity theory is spooky action. So, you know, he's guilty of, you know, this is a technicality about, you know, whether you can have a 15-year-old or a 16-year-old girlfriend. He's so close to being in the, you stupid fuck, what are you talking about? Bent geodesic. Come on. Something real is causing the effect. You can't bend nothing. What the hell is space in your definition if you can bend it? What is it? Made out of etherite? Is that what it's made out of, etherite? Oh, shit. You bent the etherite?
The battle raged for decades. Actually,
So I don't know what battle raged. I don't know. There's no evidence of any raging battle. The fact is, Einstein wrote a paper with Bogolsky and some other guy, and it totally wiped out the other side. They responded with drivel that nobody can even understand, and somehow they won the argument. So it's just obvious physicists wanted to believe in unicorns, and this is the road to unicornum. They wanted to go to unicornum, and this is how you get to unicornum.
in some ways, it still does. It was fought.
It's just religion all over again. Let's do a new religion, and we'll have a fun god instead. It'll be like, whatever, Singularilalia. And we'll sing Singularilalia songs.
Across the world, in universities, at conferences, in bars and cafes, it would.
Yeah, she never even debated the fact that, well, does 4 pounds dropped 1 foot really the same energy as 1 pound dropped 4 feet? Is that really true? Does it really take 25 times the fuel to spin something 5 times as fast? Do you think that, does that sound right to you? Sounds a little fucked up to me. They didn't do that.
Reduced grown men to tears. And it began with a
It is sad and tragic that this is where intelligence goes. It goes to dig another fucking religious hole in the cesspool. Let's just, keep making up fake crap to live for.
deceptively simple experiment.
Oh, and this is where he really goes wacky. To call this deceptively simple when he's not even going to describe the actual experiment. And there was nothing, it's really not, I mean, it's sort of simple, but it's nothing like what he's going to say it's like. I miss
But
you.
weirdly, it was an experiment that wasn't even about light. It was about the particles that make electricity.
So again, the particles that make electricity. Obviously, photons make electricity. Happens all the goddamn fucking time. So let's just say that photons push electrons. When electrons move from atom to atom, that's called electricity. Okay, that's all you have to do is move an electron from one atom to another atom. Electricity. All right.
In the mid-1920s, an experiment was carried out at Bell Laboratories.
So he says now it's the mid-1920s. It was 1922 a minute ago, and now it's the mids. But anyway, so this goes to two different places again. So it's like, this was a collaborative thing because the first experiment really didn't work, and blah, 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 blah.
In New Jersey in America, which uncovered something entirely unexpected about electrons.
All right, so they say it's something completely unexpected. So let me just explain. They're going to shoot electrons at a surface, and what they're expecting is to see the shit. They're essentially trying to invent the electron microscope. They're essentially thinking, well, if I throw electrons at a surface, I should be able to get the bounce back, and that bounce back should be in some form or another an image of what I'm shooting the electrons at. That's what they were hoping for. So they knew about this idea that the electrons are going to bounce.
Now, at the time, it was accepted without question that electrons were these tiny lumps of matter, small but solid particles like miniature billiard balls. In the experiment, they fired a beam of electrons at a crystal and watched how they scattered. Now, that's entirely equivalent to...
So he says, you just heard what he said, right? We shot it at a crystal. Now, it's not like a crystal like diamonds or something. It's a hunk of nickel, okay? It's nickel metal. So they're going to shoot electrons at the nickel metal. Now, yes, all metals are crystalline, but their crystals are very flat and big, okay? The sections of crystal, all right? And they're just, to start off, they were just shooting them straight and then see what happens. And they came off at specific angles depending on how fast you shot it in. So the faster you shoot it in, it comes out at a different angle. Not a big surprise at all. And certainly nothing like what he's just going to say, it's just like. It's nothing like.
Taking a beam of electrons, say from an electron gun, and firing it at a screen with 2 slits in it.
How is it equivalent at all, right? So you could just argue that, okay, well, there's some idea that, well, you can go through the crystalline structure, right? There's layers in the crystal, and so you could say, well, if it bounces off the first layer or it bounces off the second layer, those would be 2 different things. But there's no chance that they interfere with each other in any way. They're not going the same place. This is all just it's not like 2 electrons from 2 different locations intersected, and there's nothing like it at all. I mean, it's insane for somebody to get away with this as a physics argument. Shooting electrons at a piece of nickel is the same as shooting electrons through 2 slits. I mean, it's just not the same experiment. It's not even close. Electrons are charged, and they're going to bounce off of electrons. If you try to shoot electrons through 2 slits, it's never going to work because they're charged. Of course, they're going to bend to avoid each other. Oh, god damn.
So that the electrons pass through the slits and hit another screen at the back.
So this is just a big lie. So none of this did not happen. This was not the experiment done, and the experiment just showed angular diffraction at different intensities of voltage differential. That is how fast you were pushing the electrons.
What the Bell scientists found shocked the physics world to the core.
So that, I again say, bullshit. Prove it. Show me the New York Times headline. Einstein proven, show me. Bell Labs proves electrons are woollicles.
To understand why, consider a similar experiment with water.
So again, he's saying a similar experiment. There's nothing similar. It's zero similarity, really. I mean, there's so dissimilar that it's just not possible to say it's similar.
Waves. I've set up a simple experiment. I have a water ripple tank placed on top of an overhead projector. I have a generator producing...
Right, and so you ought to just do it with a single slit, and you'll see there's no pattern whatsoever. There's no interference. It's nothing like photons at all.
waves.
So again, look at the experiment. Where are the wave centers? Obviously the wave centers are right here in the center of the waves. That means this middle of the slits. That's not, okay, not the math. The math either uses this total distance or it uses this slit distance, but it doesn't use the center of this opening and the center of that opening. That's not the math that gets the right answer. So obviously the waves have to be on, the center of the wave has to be on the surface. It's just a huge giveaway that, oh, it's more about scatter. Yes, you're just scattering. I mean, water waves don't do what he's claiming happens.
That pass through two narrow gaps. The projector beams the image of the waves onto the back wall.
So again, you can see the center of the waves is the center of the opening. That's not what they use for the math. The math uses the point source being the surface. The surface gets the right answer. The wave being on, the center of the wave being on the surface, right where the surface is. That's the math that gets the right answer. Not this fake, phony bullshit.
You can see is
it also doesn't create the double maxima in the middle. It doesn't do a lot of things, okay? It doesn't match. It's not just like, oh, it's just so bad.
the waves come in from the left and squeeze through the two gaps. They spread out on the other side.
I mean, it's just so obvious. If you gave it a little bit of thought and you say, okay, well, what if the photons were rays and they're little tiny, thin little rays? Well, you'd say, well, 90% of the rays go straight through because they're not, they're not anywhere near a surface. And so they just go straight through. And we already know the surfaces are covered in electrons. So, and you can even see that a little bit in the sense that you see this, diffraction of the light, around this edge, indicating that something's diffracting the light. What the hell's doing that? Electrons, that's what's doing that. So anyway, I mean, it's just such, and you just say, yeah, okay, 90% of the light goes straight through, 10% gets affected by the surfaces, and only a really tiny percent gets deflected a lot. Then again, they've never even done the experiment where, they recognize that it's going, ideally you want to project it on a round surface. And they've never tried putting a photographic plate here and a photographic plate here to see if their wave theory is right. Because if their wave theory was right, they should get photons here, all the way across. Because that tank is showing you the waves are interfering in all directions. So you should get your pattern over here. Nah, you don't get any photons over there. That's why they've never done it, because it doesn't happen.
And interfere with each other. What this means is that when you get the crest from one wave meeting the crest from another, they add up to make a higher wave.
Right, and that doesn't happen with the photons. So the photons are doing something opposite to that, okay? In the sense that that doesn't work. There's not double photon.
But when the crest from one meets a trough, they cancel out. This gives rise to these characteristic lines leading to the signature wave pattern.
Bands of light and...
So we know it's not a signature pattern in the sense that the signature changes. So we know that in the double slit with photons, I'm going to get a double maxima here. I'm going to have two different patterns. I'm going to have an envelope pattern, and I'm going to have the regular pattern. We know this isn't the pattern. So again, why they say, oh, it's a signature pattern that is completely different in photons. Completely different features. And yet they'll just keep arguing that this is the process, when no, this isn't the process. And again, this is in light of the fact that they can't make photons hit photons. They can't make any force going the speed of light affect another force going the speed of light. And the only place where they claim it happens is gravity. And obviously now we're back to the Eddington experiment and quoting Eddington, I wouldn't stake my life on these results. Quoting Eddington, the data quality he got in the experiment was 1/10 of what he was hoping for. 1/10. 90% degrade in the data quality. Great experiment, right? No, not good. I'll play this and then drink.
Dark. Whenever you see these light and dark bands, the signature wave pattern, you know without doubt that you've got wave-like behavior.
All right, so again, that statement alone, a physicist should say, come on, It's an on-off pattern. I can't make a simpler pattern in the universe than on-off. I mean, we have things spinning out there in space that are doing on-off. All right, they're not interfering. They're not doing it. No, they're just turning on and off. They're spinning. I mean, it's just ridiculous to say every time I see something that goes on, off, on, off, on, off, I have to think wave interference. No, I don't. Shit. So all of this crap, and again, that wasn't what the electron experiment. So the electron experiment doesn't have the double maxima, doesn't have the two patterns, doesn't have any of the same features, and it's really just telling you, frankly, okay, that electrons are under certain amounts of tension, and so you'll change the angle at which they reflect based on how deep the photon goes into the crystal, you could argue. So the one in the middle could be the top surface, and then the bottom, the next layer creates these deflections, the next layer creates some other deflection, and you know what you're getting back, right? You could be hitting an electron straight on, and what you're really doing is pushing the two side electrons out, right? Because it's pressure. When you're sitting on the earth, right, you're not, you're pushing stuff down, and stuff over there is pushing up, that kind of thing. That's the way it works.
So, guess what they saw in New Jersey?
Now it seemed that fire...
So this isn't what they saw, okay? So it's not the pattern that they saw in 1925. All they did in 1925 was able to put the beam in and get an angle out. One angle. That's all. So this is just bullshit.
Electrons, tiny solid particles through the two gaps.
All right, so they didn't, it's no two gaps. So again, it's just a lie. So he keeps saying, this is what we did. We shot electrons through two slits. They didn't do that. And the one time they did do that, where they actually put it inside an electron microscope, because that's the only place you have to aim the electrons. You can't, you can't use scatter. So you have to actually aim them to get them anywhere near the slit. And obviously it's a substance, so they have to make the substance so weak. They did it with gold leaf, and the electrons just went right through the gold leaf. So and the thicker they make the substance, the less effect it's going to have, because the electrons are really annihilated, in the sense that their path will be completely wiped out by the fact that you're just pushing them into a charged area, and the charge is going to decide where they go, because they're charged. They're not photons. Photons don't carry a charge.
Produced exactly the same kind of pattern. Bands of light and dark.
So, and again, it's not bands of light and dark. So that's not what the light pattern does. It creates a double maxima. And like I said, in the double slit, it creates two patterns, an envelope pattern and a little bar pattern. That's perfectly consistent with the math of recognizing that the two outside surfaces are making the small bars, and the two smallest distance between two surfaces, the closest point sources, are making the big envelope bars.
First, light, for a long time believed to be a wave, was found to sometimes behave like particles, and now electrons,
It's just nonsense.
believed to be particles, were behaving like waves.
But it was actually stranger than that.
All right, so these are just such far-reaching conclusions based, like I said, they're just searching for bullshit. They're not trying to do science. They didn't come up with some kind of rational explanation that, yes, electrons are kind of big, you're shooting them into a surface, you're going to have a pattern that comes out because it's big thing against big thing.
Wave pattern wasn't merely some result of the entire beam of electrons.
More recently, this experiment
And so, and why would you think it would be? Because the electrons are repelling each other, so they'd just be going further and further away from each other. They wouldn't be connected to each other in any way. They'd just be scattering away from each other. Electrons don't like electrons. They just make a mess out of this.
has been repeated in labs around the world by firing one electron at a time through the slits.
So again, it's no slits, and So you're just saying you're bouncing electrons, and there's a probability of where they're going to end up, and that's it.
Onto the screen.
There's no need for an interferer. All you're saying is that the angle changes. So this is sort of like changing the size of the water droplets in the rainbow. You know, it'll change where you'll see the colors.
At first, each electron seems to land randomly on the screen. But gradually a pattern forms. The signature wave pattern.
So again, he doesn't show us any actual experiment actually producing this effect. So it's just bullshit. I think this is actually something that they actually did this, and you have to use an electron microscope to actually force the electrons to go through, you know, different features to actually make this pattern. So there's no slits, and it's just bullshit.
Let me be quite clear about
just be quite clear about what a preposterous fibber you are, okay? Because you just made a big giant fib. This is not what took place. It wasn't a double slit experiment. It's not the same experiment. You're a fibber.
how weird this is. Remember from the wave tank experiment where the signature wave pattern only exists because each wave passes through both slits and then its two pieces interfere with each other.
Right, and if you use that math, if you use that concept in the math, you'll get the wrong answer. So if you use the center of the slits as the distance, creating your vectors of interference, you'll get the wrong answer. Clearly, that's not what's happening. The photon is not waving through the slit and scattering from the center of the opening. It's not happening that way.
But here, every individual electron, each single particle, is passing alone through the slits before it hits the screen.
And it wouldn't make any, again, it does make a difference. Obviously, with photons, you're reconstructing photons, so if you don't have the other slit, it won't work. All right. But obviously, electrons are not passing through both slits. It's just a silly thing to say. It ain't happening. We can see electrons. It's a whole different game being played. We can know where the electrons. We have to know where they are. That we can't get them. We can't get them to go the right way unless we aim them.
And yet, each single electron is still contributing to the signature wave pattern.
Each electron has to be behaving like a wave.
No, each electron happens to be going through an obstacle course, and one of them trips on the first banana peel, the other one tripped on the third banana peel, the next one trips on the fifth banana peel. That's all. There's obviously a variable that creates the variable outcome. Jesus.
To explain this strange result, Niels Bohr and his colleagues created quantum mechanics, a crazy theory of light and matter that embraced contradiction and didn't care that it was almost impossible to understand.
And silly and stupid and wooey and made for children, frankly. You might as well just call it gremlin mechanics.
As Niels Bohr himself said,
Hobgoblin mechanics.
anyone who isn't shocked by quantum theory hasn't understood it. So, viewers, I'm going to take our tiny electron and use it to delve deep into the heart of reality. And yes, prepare to be shocked, because this is the only way to explain what we observe when a single electron...
So we can't trust his observations, right? Because we just saw what he did. He just lied about how the experiment works, what took place, and what the outcome was. He just made up a fable, okay? He tried to convert the electron experiment into the photon experiment, and they're just not the same. Not even close.
travels through the slits and hits the screen.
Quantum mechanics says this: we can't describe what's traveling as a physical object, all we can talk about are the chances of where the electron...
So we know that the slits are gigantic compared to the pieces of the stuff it's made out of, the bits. So, there's just no, the very idea that the same photon is going through both slits or the same electron is going through both slits is just so silly.
Might be. This wave of chance somehow travels through both slits.
And ends up mostly hitting in the middle a lot more than everywhere else. Why would it do that? Oh, maybe because it doesn't do any of this crap and most of the electrons just go straight through. So obviously, again, they didn't do this experiment. So again, that's why he's simulating it. It's because they don't do this stupid experiment. You can't shoot charged objects through material slits. You can't do it with any kind of, oh yeah, we're going to find out what the property of the slit is. No, you're going to find out what the property of the charge on the surface is.
Producing interference just like the water wave. Then, when it hits the screen, what was just the ghostly possibility of an electron mysteriously becomes real.
Then how come it has a different pattern? If you're saying it's doing the same wave thing, two waves coming out, blah, 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 interfering, then how come the patterns aren't the same? How come the double slit in light has a double maxima? How come?
Let me try and capture just how weird this is with an analogy.
So another one of these terrible analogies, no doubt.
If I spin this coin, then all the time it's spinning, it's a blur. I can't tell if it's head.
All right, so whatever. This is just, pretend. We're just going to pretend because our vision is limited that coins don't have real positions and they don't move through each one of those positions and all of that doesn't happen, when of course it does.
Heads or tails. But if I stop it, I force it to decide, and it's heads.
So this is the measurement thing, right? Which is also a joke, right? Because everything's getting measured all the time. See, they're saying, okay, look, I took a photograph of it. Well, yeah, you took a photograph. Well, what happens when you take a photograph? Well, you're just getting light bounced off the surface. Well, light's bouncing off the surface all the time. It doesn't matter whether I take a photograph or not. It's already been outed as being somewhere because a photon hit it. And I could just argue that if you believe gravity's a force, well, gravity's hitting stuff all the time. There's no place you can go where nothing's hitting you and nothing's reflecting off of you. The signal of your existence is always being sent. There's no place you can hide where the force can't get to you, okay, and you don't reflect anything, giving away your location. Of course you do. So why would it matter whether there's film in the camera? It has nothing to do with it. I mean, it's that bad. That's what makes it a religion, is the fact that they can't even concede there's no such thing as us measuring. The universe measures all the time. You could take a picture of your screen any moment, okay? It's making the picture whether you're taking the picture or not. The light is hitting a location, whether you put film in my hand or not. It doesn't matter whether there's film in my fucking hand.
Before, it was sort of not heads or tails, but a mixture of both. But as soon as I've stopped it, I've forced it to make up its mind. This is what Bohr and his supporters claimed was happening with our electrons.
Which is too silly, right? Just pointing out that there's no point where the electron isn't being detected by the universe. The universe is watching it all the time. And we're just saying, well, we can't see the picture because there was no film in the camera. Well, so what? We don't need to see the picture to know the photons hit it and they reflected.
In a sense, as it spins, the coin is both heads and tails. Similarly, the electron's wave of chance passes through both slits, two paths at the same time.
And doesn't get the right pattern. So again, just pointing out, the patterns don't match. So it obviously can't be the same mechanism because the patterns don't match.
Horn then stops at heads. The ethereal wave of probability hits the screen and only then becomes a particle.
So ethereal. So we know where, their bent is. So again, just a silly explanation. And again, there's no point in me talking about the electron experiment because this isn't how the electron experiment is done. So it's ridiculous to talk about it as if this is a real experiment and I have to explain it. But if we understand that this is photons, I can explain it by simply stating the surface is covered in electrons. The photons, pieces of the photon hit the electrons and pieces are scattered off those surfaces. And they're scattered in all directions. Depending on how many electrons they hit, the more they're scattered. And it's just a matter of 50-50 putting them back together again. 50% of the photons will go back into phase and 50% will go out of phase. And all of the scatter will be in this plane because all of the electrons are moving in and out of the surface. So the electrons are all going this way, in and out. You're shooting your photon this way. And so obviously the scatter will be that way or that way. Perfectly describable. Perfectly explainable with a quantum theory of photons, a particle theory, not a wave theory.
The quantum world was unlike anything ever seen before.
It's unlike anything, period. It's bullshit. Okay, it's a fable. It's a silly story. He might as well be saying fish do talk. It's just that they do it in a very high frequency and we can't hear it. Or some kind of crap like that. It's just so bad. Alright, continuing.
It's hard to overstate just how crazy this is.
No, yes, yeah, I'm just saying, and the very fact that they're saying that, just conceding that, okay, we've based all of this insanely crazy idea on silly analogies and poor explanations of experiments. Really completely unrealistic description of an experiment. Again, they say that Stern-Gerlach, where you're shooting ions, okay, actual physical atoms of silver, and they're saying, or measuring electron spin. What?
Bohr was effectively claiming that one can never know where the electron actually is at all until you measure it. And it's not just that you don't...
So again, and his model is so wacky that it fits in a sense because, yes, the whole idea of electrons spinning around at whatever 400 meters per second or whatever the velocity is spinning around atom, it just doesn't make any sense.
know where the electron is. It's weirdly as though the electron itself is everywhere at once.
So just too ridiculous, right? We know the matter's held together based on sharing an electron. Sharing something that doesn't have any position, well, screw that. That ain't going to work.
Bear in mind that electrons are among the commonest and most basic building blocks of reality.
I don't know what commonness means. So you get, yeah, I mean, you can pick at everything, right? But I mean, just, what do you mean common? What he should say is, well, electrons and protons are real physics, and all the other crap you've heard about, neutrinos, positrons, that's all shit. Okay, just ignore all that crap, and just electrons, protons. That's all you need to make a universe. You don't need all this other crap.
And yet, here's Bohr saying that only by looking do we actually conjure their position into existence.
So again, this looking thing is just too silly. There's no such thing as whatever a looking is. when we're looking, we're not even doing anything. It's not like we shoot, our eyeballs shoot rays at it and they bounce back or something. It's already being looked at. I don't have to, again, I don't have to say, I'm going to look now, turn on, so I can look at you. It's already on. The movie's already playing. I don't have to walk into the theater for the movie to be on the screen. Shit.
It's like there's a curtain between us and the quantum world, and behind it.
So again, it's just that this is all little tiny stuff, and it's really tough. You got to dissect the truth out of a bunch of little tiny pieces of evidence, but you got to do it carefully and with some sort of discipline. And they show none. They just jump to the first wacky, give me the silliest idea you can think of, and they all just jump on that bandwagon. Dark matter. Well, maybe there's matter that makes gravity but doesn't do anything else. Maybe there's men who are invisible, okay, but they do lots of stuff. They steal your socks and they do lots of stuff.
There is no solid reality, just the potential for reality.
Oh, god damn. You just want to, It's so frustrating. I mean, we spent thousands of years wallowing in silly religions. The 1700s come along and we're finally growing up, and then we just decide to just jump right back in the sewage.
Things only become real when we pull back the curtain and look.
And this view, ladies and gentlemen, became known as the Copenhagen interpretation.
And we know that. So right there, why bother even saying it, right? Because only 25% of physicists believe in it. So what's the point of having your silly interpretations? But they're all silly. That's the problem. Many worlds, new universes created. I mean, they're all silly.
Persuasive as it might seem, many people couldn't stomach Niels Bohr's outlandish ideas.
Yes, if I was there, I would have certainly wanted to throw up on his feet. Fuck. It's terrible nonsense.
And they found a natural leader in the most powerful man in science.
Albert Einstein hated this interpretation with every fiber of his being. He famously said, "Does the moon cease to exist when I don't look at it?"
Yeah, and he probably was saying lots of stuff. I mean, it's just, because there's like 4 million ways to say, what are you, insane? Oh, god damn it. Do you really, I mean, what? When I'm looking at the moon, what am I doing? Oh, that's right, I'm not doing a damn thing to the moon, right? It already happened. The photon was already, it took a second for the photon to even get to me. What am I? I'm not doing anything. Obviously, whatever the process is, it was happening when I wasn't looking.
He was very unhappy because it gave limits to knowledge that he didn't think should be final. He thought...
No, it didn't give any limits. It just created this silly idea that it's not a real universe, made out of real stuff that's really moving around and doing things, that it's a cause and effect mechanical universe. They're basically saying it's not a cause and effect mechanical universe, it's some fucking wooey nonsense-averse, where just little magical things happen for magical reasons.
There should be a better underlying theory.
It's so obviously consistent and mechanical in its function. It's so reliable. I mean, a photon could travel billions of light years, and everything's perfect. It's imperfect. It's just the way it left. It's just, there's just no way to say that this universe has any of this woo in it, because it does things over such insanely long periods of time without any error.
Over the next 10 years, Einstein and Bohr would argue passionately about whether quantum mechanics meant giving up on reality or not.
giving up on mechanics or not. But again, see, Einstein already did that by taking gravity out of the mechanical force universe. Now, I don't know if he did that entirely on his own. I mean, that's people's interpretation, because there are places where he implies he believes in an ether. He's basically saying the space is the ether, and that's what's bent.
Then, with two other scientists, Nathan Rosen and Boris Podolsky, Einstein thought they'd found a way to win the argument.
So they're really making a terrible, they're making a joke out of how silly the idea is, because they point out that what this means is, okay, that you could create two things, and if they're amorphous, you know that they start off being something, left, right. Then they go into amorphous mode, and then you could find out what one thing was by finding the other thing would have to know what it's supposed to be. So I don't know exactly how they got to that part where the two would get mixed up. But anyway, it doesn't matter. Let's just play along.
He was convinced he'd found a fatal flaw in the Copenhagen interpretation, and its claim that reality was summoned into existence by the act of looking at it.
At the heart of Einstein's argument was an aspect of quantum mechanics called entanglement. Now, entanglement is this special, incredibly close relationship between a pair of...
All right, so now as I understand it, entanglement wasn't a concept until Einstein used it to make fun of measurement bullshit. So in a sense, Einstein invented entanglement to make fun of entanglement.
quantum particles whose fates are intertwined. For example, if they were created in the same event.
Right, so they're creating the same event, and one of them has to be a certain thing because the other one's this thing. But you don't know what this thing is until you find out what that thing is, and vice versa. And somehow they would have to communicate, because you are saying they can be either one. They can turn out to be, this one can be an A or it can be a B, depending on when I put my hand on the coin. And the fact would have to be that the other one would have to be the opposite. If they had opposite polarization, for example, then somehow the other one would have to have, because this one was an A polarization, that one would have to have B. And if this one was a B, that one would have to have A. And somehow, how could it know what this happened here? How could it tell when that one got de-entangled? It's messy. It's stupid. Having to waste time even talking about how it's paradoxical and nonsensical is paradoxical and nonsensical. You shouldn't have to do it.
Let me try and explain this by imagining the two particles are spinning coins.
So, yes, and so what we do know is that the two particles in all of these tests are going to be photons with polarization. And so it's a physical property, a real thing, not a fake thing. It's something they really do have.
Imagine these coins are two electrons created from the same event and then moved apart from each other. Quantum mechanics says that because they're created together, they're entangled. And now many of their properties are forever linked, wherever they are.
Remember the Copenhagen interpretations.
So that's really not the statement. The statement is that the two things were created in the same event, and so you know they have the same property. And what you're arguing is that you can change their property. And if you change one of them's property, then you have to change the other one's property. And somehow you have to, how does it know you changed the property? Because you're changing the property based on some event where you're going to decide whether it's going to be A or B. And how does the other one know, now I have to be an A, or now I know I have to be a B? How can it tell that? How can it know that?
Says that until you measure one of the coins, neither of them is heads or tails. In fact, heads and tails don't even exist. And here's where entanglement makes this weird situation even weirder.
When we stop the first coin and it becomes heads, Because the coins are linked through entanglement, the second coin will simultaneously become tails.
So simultaneously, whatever that means, right? You know, instantaneously. I mean, it's just too ridiculous. So they don't have anything called evidence of this crap, right? So this is just all made up bullshit. And it's bullshit. It's nonsensical as an idea. You know, you could think, I've made the argument, I would think, right, if this entanglement thing was real, nature would have found a way, kind of thing. You know what I mean? Evolution would have figured it out. Just like it made all our tools that work, it would have figured out this tool that it could take advantage of, where we could know in advance what's going to happen. You know.
And here's the crucial thing. I can't predict what the outcome of my measurement will be, only that they will always be opposite. Einstein seized on this.
Because it meant that something was happening between the two coins that was almost too crazy to imagine.
All right, so we just know it's too silly to imagine. That's right. We know that the speed of light is the limitation in the universe. There's nothing going faster than the speed of light. The whole thing creates insane, nonsensical paradoxes as soon as you create such a thing. So why even play with it? It's just ludicrous nonsense.
It's as if the two coins are secretly communicating instantaneously across space and time, even if the first coin was on Earth.
So it's like there is no it. So just understand, the coins don't do it. Nothing does this. This is just storytelling. There's no it here. It doesn't do it.
And the other was on Pluto.
Einstein refused to believe this instantaneous, faster-than-light communication. His theory of relativity said that nothing could travel that fast.
Well, the limitation on travel is the fact that the speed of force is the maximum speed. If the fastest you can run is 60 miles an hour, then the fastest you could push something is 60 miles an hour. You can't make it go faster. So obviously if the speed of force is the speed of light, then the fastest the force could ever push a piece of matter is the speed it's going. It can't push it faster.
Not even information. So how could one coin instantaneously know how the other would land?
It can't. It's nonsense. I don't know why people believe it. It's just so depressing. Alright, so this might be enough of a video. So yeah, we'll probably go with 3 parts as the usual routine here. So I will return next time, and then we're going to be getting to the guy I really dislike, aspects bullshit experiment. Alright, so till the next time and such and so forth and whatnot.